Example 11, we are told to sketch the graph of y is equals to x squared minus 5x plus 4 and find the coordinates of the turning point. And find the coordinates of the turning point. First of all, we must understand the shape of the graph. That our A is 1, which means A is greater than 0 and the shape is a U. At the same time, where does the graph cut the y-axis? The graph cuts the y-intercept. What is the y-intercept? It cuts the y-axis when x is equals to 0. We have seen in the previous example. That means that y is equals to 0 minus 0 plus 4. So the y-intercept has coordinate 0, 4. So this is the y-intercept. If we are to sketch the graph, okay, let's have it here. Let's have it here. We will talk of 0, 4. That is the y-intercept. Where does the graph cut the x-axis? Where does the graph cut the x-axis? This is x and this is y. The y-axis intercept happens when the x-axis intercept, happens when y is equals to 0. And that one is when the whole of this function is equals to 0. So x squared minus 5x plus 4 is itself 0. So this one just becomes a normal quadratic equation which can be solved using BAC approach. And our B is minus 5, our AC is 4, of course minus 1, minus 4. Both are the two factors. So we have x squared minus x minus 4x plus 4 is 0, x minus 1 minus 4, x minus 1 is 0, x minus 1, x minus 4. When the two products are multiplied out and the answer is 0, then it means either of these is 0. If this is 0, then x is equals to 1. Or if this is 0, then x is equals to 4. And these are what we may call the critical values. These are the solutions of this particular function. They are the roots of that function. So 1 and 4, 1 and 4, these are the very critical values, or rather the solution. And because we have already seen that the shape is a U shape, we can now easily sketch our graph this way. And this is the graph of y is equals to x squared minus 5x plus 4. That is as far as the second part of the equation is concerned. But the third part is asking us find the coordinates of the turning point. And we have been told that the coordinates of the turning point, you have to get the coordinates after you complete the square of the original function, which is x squared minus 5x plus 4. Completing this square, we have x minus 5 over 2 squared minus 5 over 2 squared plus 4. And you can already see that you have something to do with x minus 5 over 2 minus this squared is 25 over 4 plus 4. When we have minus 25 over 4 plus 4, if you just add an LCM, if you consider the LCM of this particular part is 4, 4 divided by 4 is 1, minus 25 minus 4 divided by 1 is 4 minus or rather plus 16, and the final one is becoming minus 9 over 4. So the general completed the square statement is x minus 5 over 2 squared minus 9 over 4. This one is already in the format. Of x plus p squared plus q. And once it was, we were told in the previous example that the moment you expand it this way, or it could be having an a, then the coordinates of the turning point is the coordinates is minus p q. So in this case, our p is supposed to be minus 5 over 2. So the turning point coordinates is actually the negative of minus 5 over 2 and the negative of minus 5 over 2, and the q is negative 9 over 4. So this one is simply positive 5 over 2 minus 9 over 4. Those are the coordinates of the turning point. Please note, for us to get the coordinates of the turning point, we had to complete the square first, so that we can write it in this format and then pick our minus p q. And this is exactly what we have realized. But we are also told that we can get the coordinates of the turning point once we consider what we may call symmetry. And we would want to know what is the value of y, what is the value of x at this particular point, because that is the turning point. What is the value of x? It is midway from between 1 and 4. It is midway. The turning point is midway between the two roots of the function. So what is the x value of that particular point? So 1 plus 4 over 2, which is 5 over 2. And the moment you get 5 over 2, substitute it in the original function, then this is x is equals to 5 over 2. Substitute it in the original function, y is equals to 5 over 2 squared minus 5 over 2 plus 4. After you do all these calculations, you realize that y is going to be minus 9 over 4. So either way, the turning point has coordinates 5 over 2 minus 9 over 4. Either way, you will get there. And it is important to note that you can get the turning point using completing the square method or using the symmetrical approach method. Okay,